All right, let's talk about something that is absolutely critical. If you want to write code that's not just functional, but truly professional and tough enough for the real world, we're diving into exception handling. So let's just jump right in with a big question.
Seriously, think about it. What is that one thing that takes code from just being good enough to being genuinely great? Well, it's not just about what your code does when everything is going perfectly. The real test is what happens when things start to go wrong. And believe me, things definitely go wrong. Picture this, a travel booking system. Someone's about to book their dream vacation. They hit confirm, but the payment gateway times out. Without the right planning, the whole app could just crash. Poof! The booking's gone, the customer is furious, and the business just lost money. That's exactly the kind of chaos we want to avoid.
But what if your code had its own built-in safety net? A way to see these problems coming and catch them before they can do any real damage. This totally changes the game. Suddenly, errors aren't disasters anymore. They're just predictable events we can actually manage.
And that safety net? Well, it has a name: exception handling. It's the process of responding to these unexpected events, these exceptions, so that your program can keep on running, or at the very least, shut down gracefully without bringing the whole house down with it. It's how we bring order to that chaos.
So why is this so important? Well, for starters, it prevents those catastrophic crashes. It also makes the user experience a million times better. A nice little, oops, something went wrong, please try again message is way better than a screen full of gibberish. It also helps keep your code tidy, lets you log all the important details when something does break, and this is the big one. It gives you a chance to actually recover from the error.
Now, to build this safety net, you've got this simple, super powerful toolkit. It all comes down to 3 key words that are the absolute foundation of exception handling: try, catch, and finally. Let's see how they all fit together. You can think of it like a 3-step safety drill. First, you tell your program to try a piece of code that you know might be a little risky, like talking to a database or reading a file. Second, you get ready to catch a specific error if that try part fails. This is your game plan for when things go south. And third, you have a finally block. This is cleanup duty. This code runs no matter what, whether everything worked or it all went up in smoke.
Okay, let's look at some actual code. Here, we're trying to read from a file, which is a classic spot for things to go wrong. The risky part is right there in the try block. If the file isn't there or something else bad happens, the catch block jumps in, grabs the error, prints a helpful message, and stops the app from crashing. And no matter what, that finally block runs at the end. It's just a clean, predictable way to handle risky business. Okay, but hang on a second. Look at that last example again. We used catch exception X. That's kind of like throwing out a giant net to catch, well, anything. Is that really the best way to do it, or could we be a little bit more, surgical about it?
This is where you really start to level up. Catching that general exception is a bit of a blunt tool. Yeah, it catches everything, but that might actually hide bugs you don't even know you have. But catching a specific exception, like FileNotFound exception, that's like using a laser scalpel. You know exactly what went wrong, and you can take a specific action, like telling the user, hey, that file doesn't exist, instead of just a vague something went wrong. It's so much more robust. And there are a ton of these specific exceptions you should keep an eye out for. You got timeout exception for when a network call is taking forever. SQL exception tells you there's a problem with your database. Knowing these specific types lets you build custom-tailored recovery plans for all kinds of predictable problems. But what happens when the built-in exceptions just don't cut it? What if you have an error that's totally unique to your application's logic? Well, this is where the real pros shine. You can actually craft your very own custom exceptions.
And check it out, it's actually pretty simple to do. Here, we've just created a brand new BookingNotFound exception. Now, in our travel app, if someone looks for a booking that doesn't exist, we can throw this super specific, super meaningful error. This makes our code not just tougher, but a whole lot easier to understand.
And this right here, this shows you a really professional, layered strategy. You can specifically catch a timeout exception from the payment gateway and automatically retry the payment. But you can also have a general catch block that acts as a final safety net, just logging anything else that was totally unexpected. It's smart, it's layered, and it's how pros build software. When you get right down to it, exception handling isn't just another technique you sprinkle into your code. It's a fundamental shift in your mindset.
You're moving away from being reactive, frantically fixing crashes after they happen, to being proactive, designing your code from the ground up to expect and handle failure gracefully.
So, what's the big takeaway here? It's all about this journey from chaos to control. You start to anticipate where things might break, you isolate that risky code in try blocks, you handle specific errors with smart, targeted plans, you even create your own custom exceptions. And when you do all that, you're not just building apps that work when everything's perfect, you're building apps that can endure, that can survive the storm.
Which really just leaves us with one last thing to think about. Is an error truly a failure of your program? Or is it an opportunity? An opportunity to be clearer with your user, to make your system stronger, and to build smarter, more resilient software.